Hey guys, welcome to another YouTube video. It has been a little bit since I have released a video, but that is because life has caught up with me. But today we will be talking about the Chia-Proof-of-Space Plotter and some tips and tricks on how to get the best performance out of that one. This one is the one that is built in with the GUI, and it's the original one. And let's go ahead and dive right on in. So the first thing we do need to do is we do need to copy down some information if we do want to be pooling. So what I mean by information is we're going to need the farmer key, the public pool key. Depending on who you pool with, we may have to vary it or give them both or several of them. And let's go ahead and get those here first. So we're going to go down to the keys tab here. Once the keys tab has been selected, we're going to hit the eye icon and we are going to get these items here. We really just need the bottom two here, but we're going to just copy everything. So Control C, and we'll open up a text editor just to paste here. There we go. All right, so now that we have this here, we're going to click back into the tab here. And now we're going to go ahead and get to the actual plotter itself. So let's go ahead and click on plots, add a plot, and here we have the entire layout of what we will be working with. Let's go ahead and take a look here. So the first one, like I said, we're doing Chia-Proof-of-Space. As you see, they do have different variants here. So number one, just Chia-Proof-of-Space. And then if we scroll down, the next portion here is choose a plot size. So it is important here to pick the correct one. Otherwise, it may not work. It's going to be very, very slow, or it's just not needed at this point. So over here, when we click on the drop down, as you see, there's different sizes here and different sizes here. The ones on the left are approximately the finished size of the plots. The one on the right is what is needed to create that, and then the middle is kind of just the name or shortened abbreviation of the plot. So with the first one here, as you see, it's 600 megabytes approximately. It is temporarily needed to have 1.8 gigs free approximately in order for this here to get plotted out and joined together. And it's the same thing here, 101.4. 239 gigabytes needed approximately, and then the more unreasonable ones here are the 208.8 needing 512 or 21 gigabytes of space free, 429.8 needing 1041 free, and then 884 and needing 2175. So the first one here, 600, we can't really utilize that because it is not going to be able to connect to the mainnet if you pool, so that one's kind of just out there just to test or like maybe self pool. The bottom one here, the K32, this here is the one that I use. It's the one that most people use just because it's not going to get I guess obsoleted in the meanwhile. And then the other three down here is more like future proofing, and as you see, there are different requirements meant for it. So if you don't have this here, it might be kind of hard to like plot, and if it's definitely like a lower end rig, it's just going to take super long, and nobody has time for that. So for this one, we're going to pick the K32 plot, and like I said, this is a normal one. I have like 5,000 of these approximately. We're gonna go ahead and go down to the next section though here, the choose number of plots. So this section is definitely going to vary per rig. It's not gonna be the same across like for everyone, just because everyone has different processors, speeds, clocked, RAM amount, and so forth. So here we have add plot to queue or plot in parallel, and I'll kind of explain that here. So the plot to queue is where you have one plot being made and you have another one that's kind of pending. When the first one finishes, the second one is going to automatically start. This one is good for lower end systems such as probably I'd say i3, I'd probably add a plot to queue, maybe even some i5s. And then on the Ryzen side, I'd probably say like Ryzen 5 ones may be able to do this here or this here. Like I said, it depends on the other hardware though, so you might have to play around with that. The plot in parallel though, what this one is it does more than one at a time, and what you can do is really neat. So for instance, if I have one plot being made, it takes 20 minutes, I could put a 22-minute delay on it, and this is going to automatically start the next one here. Or if you do 0, you can split your hardware resources, and if you have two, for instance, getting made, one's going to do like 5%, the next one's going to do 5%, and since it's like a similar portion there with like the writing or the reading or the rearranging, it kind of works really smoothly. In the long run, the plot in parallel does save you the most time, but like I said, depending on hardware that you have, the add plot to queue might be a better choice. For this one, we'll just hit add a plot to queue here, and then we're going to show the advanced options. Here we have the keys, here we have a couple other final options here, and then here we even have the resources that we can work with. So for the RAM usage and the threads, it is very, very important we don't overstep our boundaries with that. What I mean by that is we do need to leave resources available because the operating system needs it. Some background tasks might need it as well. So for instance, for RAM, let's just say you have 8 gigabytes. You do not want to use 8 gigabytes because that can cause the software to crash, it can cause your computer to crash, and you just might get a really, really bad performance with it since it is fairly CPU intensive. So if you have like per se 8 gigs of RAM, you want to leave at least 2.5 for the operating system, and then that will allow you to put in like 5.5 gigs for the actual plottage there. And then for threads, same thing. If you have 8 threads and a 4-core CPU, you don't want to use 8 threads. Rather, you want to tone it down to maybe 6, maybe even 7, depending on the overall system that you're running with. Once again, the number of buckets we don't really change. This here is recommended, the 128 there by default. You can play around with it and drop it to 256 and see if you get better results on that. Like I said, once again, it kind of depends on the hardware you use. And then for the queue name, you can just write whatever. So I'm just gonna put like 1, 2, 3, and I did not have my number pad on, so for instance 1, 2, 3 like that. These bottom options here disable bit field plotting, so if you hover over it, it does actually give you a question mark in case you forget what it is. But this here is going to have less overall write speeds, and it is almost faster. If you have a earlier CPU, you might want to disable that just because it can cause more resource usage and they just aren't that well optimized for this task. The next one here is exclude final directory, and if you are plotting on a disk plotter drive, which is slower, like I mentioned in my hardware tutorial or the overview video, we're going to see that this here is going to skip the entire writing phase. Wherever it's being made, that is where it's going to stay. I never have the check mark just because I don't have that type of setup there. Now if we look here, this part's for like the pooling portion here. We have farmer public key and pool public key. So if we go to farmer public key, we can go ahead and get that copied right here. So copy, and then we'll go here and Control V, and then for pool public key here, we're going to go ahead and copy that as well, and then Control C, Control V. There we go. So that's it for the plotting portion there. We're gonna now scroll on to the next one. Select temporary directory. So This here is where the plot is going to be created, and you can have two. So this here is where you would want to put the M.2 location, or you can go ahead and pick a SSD, where if you have to, you can put in a regular disk plotter drive. All you need to do is know the letter or the name of it, and then you would just hit browse, and then you would be able to hit other locations, and then if you have any like SSDs or M.2s, you can pick from here. I am in a virtual machine, so I actually only have this computer drive here. And the neat thing is you can split the temporary directories. So plotting is very, very hard against just like the drive itself. And the neat thing is we can have two, and this here kind of splits the burden between the two directories. So if you have two M.2s, if you have an older one that's performing a little worse, then you can go ahead and put that as like the second location, and then the first one is going to be your really well performing one, and it's gonna split it up. You're not gonna have as much wear on the one M.2, and then like for instance the other M.2 drive is going to still perform some tasks, so it's gonna even it out there. And I have noticed faster times, depending on, once again, the hardware kind of. You don't want to have like a super slow one and then a super fast one, but if you have some relatively even like chips and stuff, you can go ahead and get those worked out real nice there. So the next part here, final directory, this here is where the plot is gonna finish. So the final thing here would be like an internal drive that you have. You could put in an external drive that might be just floating around, or you can put it on the big external drives from like the 2 terabyte range to 20 terabytes, and that's where it is going to be located. So the next thing here is join a pool. I won't really go too in depth with that, but if you want to join a pool, you can pick which one to join, create a plot NFT, and you will have to grab some mojos from like a faucet source. But when you have that, that's going to allow you then to go ahead and join a pool. So I'm not actually gonna hit the create button here just because I don't have any resources on this virtual machine, but you would hit the create button, and then the actual plotting is gonna start, and it's gonna give you like a status graph with how much percentage is done. Once it's done, it will be able to get added to the page here. You just have to hit the plot directory or press the drive where it was plotted to, once again other locations, and then you'll be able to select from there, and you will be officially farming right after that. Thanks for watching, hope you enjoyed, and please consider liking and hitting that subscribe button so you can stay updated on Chia videos, tutorials, and troubleshooting.